Today you're going to look at section 2.3, and I just need you to change, the proportional reasoning was from 2.2, so just change that to say graphing linear functions. And you need to be able to determine whether a function is a linear function, and to be able to graph a linear function given 2 points, a table, an equation, or a point and a slope. So let's first go over what a linear equation or a linear function is. And it is a function, and remember that from earlier in the year, a function is a set of ordered pairs in which every input x is paired with exactly one output y. Now, a linear function has a constant rate of change. Linear functions can be written in the form f of x equals mx plus b, and last year you saw it a lot as y equals mx plus b, or slope-intercept form. And x is the independent variable, m and n are constants. And when we talk about the rate of change for a linear function, we're talking about slope. Slope is the change in f of x, or y, over the change in x. So it's rise over run. You probably heard that before. And this is the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it's rise. Rise indicates you're going up, or actually if it's negative you go down. So the y's in the numerator, x's in the denominator. Y-intercept is the y-coordinate of the point where the graph intersects the y-axis. And the x-intercept is the x-coordinate of the point where the graph intersects the x-axis. So we'll be using that for graphing in just a few minutes here. Now, in order to tell if you have a linear function, you need to look at the table, and because linear function has a constant rate of change, the slope has to be the same between all of the points. So what you're going to do is you're going to look at the x's, subtract from right to left. So 25 minus 18 is 7, 18 minus 11 is 7, 11 minus 4 is 7. So that is constant. Now we need to check the y's. You have to check both the x's and the y's. If there's not a constant rate of change between the x's, then you don't even have to check the y's. So again, from right to left, we're going to do negative 33 minus 20, or minus a negative 24, which will give you negative 9. Negative 24 minus a negative 15, again negative 9. Negative 15 minus a negative 6, again negative 9. So the rate of change in f of x is going to be negative 9. The change in x is going to be 7. Now again, the y's go in the numerator and x is in the denominator. So this is a constant rate of change. It's the same. It is negative 9 over 7 for all of those. So that it means that it's a constant rate of change, so it is a linear function. Now, for the next example, example B, we're going to do the same thing. We're going to subtract from right to left, 4 minus 6, 6 minus 8, and 8 minus 2. Okay, so we've checked the x's. You have to check the x's first. Now we're going to check the y's. Negative 7 minus 1 is going to give you a negative 8, and 1 minus 5 is going to give you a negative 4, and then we have 5 minus 7, which is a negative 2. Well, we could stop right here. We really don't even have to do the last one. As soon as you have one that is different, you can stop. So I just put a slash for the change in f of x, and then the change in x is a negative 2, but we don't have a constant rate of change. This is not the same as this. So for that reason, it's not a linear function. So that's all you have to do to check to see whether or not you have a linear function. All right, let's move on to graphing linear functions. And when you graph linear functions, you can graph with several different pieces of information. The first one we're going to do is using a slope and a point. So this really should be a lot of review from Algebra 1, from geometry, so we're not going to spend a ton of time on it. So using a point and slope. Okay, so we have a slope of 4/3. So that means you're going up 4 on the y-axis, over 3 on the x-axis. It's going to pass through the point 3, 1. So the first thing you'll do is graph that point 3, 1. So 3, 1, and then you'll go up 4 and over 3. Now remember, with slope, you can either go, if it's positive, you can go up 4 and over 3, or you can go down 4 and to the left 3, because this is the negative direction, this is the negative direction, so negative over negative is a positive. So the slope is still 4 over 3. So if you run out of space, you can always go in the opposite direction. Okay, finding the intercepts when you find the intercepts, if you just find the x and the y intercept, you can graph a line that way as well. So when you're finding intercepts, in order to find the x-intercept, you set y equal to 0. So an easy way to do this is if y is equal to 0, just cover that up. And you have 6x equals 12. So 6x equals 12 means that x is 2. That's where where you're going to put the point on the x-axis. If you want to find the y-intercept, you set x equal to 0. So if you want to find y, cover up x. So that would give you negative 2y equals 12. So your y-intercept is going to be, oops, I didn't write it down here. The y-intercept equals negative 6. So we go to the graph, and on the x-axis we put a point for the x-intercept, which is 2. Go on the y-axis to negative 6, and then you just connect those 2 points. So that's using a slope and a point, and also using the intercepts. And now we're going to graph using slope-intercept form. So again, slope-intercept form, y equals mx plus b, where m is the slope and b is where, so let's do that. M is the slope and b is the y-intercept. Okay, now, this is not in slope-intercept form. So the first thing that you have to do is put the equation in slope-intercept form, which means you need to solve for y. So I'm going to put a little box around y, which means I need to get rid of that negative 2x. So doing the opposite, I add 2x to both sides, and that leaves me with a negative, oops, sorry. That leaves me with a negative y equals 2x plus 6. And then I have to just divide everything by a negative 1 because I want a positive y. That's going to leave me with y equals 2x minus 6. So now I have my slope. My slope is negative 2. My y-intercept is negative 6. So graphing negative 2 on the x-axis and negative 6 on the y-axis, I can just connect those 2 points. Now there are 2 special lines that you need to remember, vertical and horizontal lines. Those are when you just either have x equals a number or y equals a number. And sometimes students get these two confused. What you want to remember is that the line x equals a number has to cross the x-axis. The line y equals a number has to cross the y-axis. And the reason why is that, let's say we have a line that is x equals 3. So let's just go put that on here, 1, 2, 3. I'm going to make that purple. Oops, not a very good line. I probably should use a ruler. Okay, this is the line x equals 3. No matter what point I pick on this line, it has an x coordinate of 3. So that's all I need to know in order to tell what the line looks like. X equals 3. If I go to 3, it has a, if I go to 2, there's an x coordinate of 3. If I go to 3 for y, x coordinate of 3. So every single point on this line, the y coordinates are different, the x's are not. So I only need to say x equals 3, and that's enough to tell me that that's what that line looks like. Same thing with the y. If I say y equals negative 2, y is always going to equal negative 2, no matter what the x coordinate is. So that's enough to give me this line, y equals negative 2. Okay, you have a few questions to do on the next page.